There we go. Hi everyone, welcome back to Lightning Lessons. Tonight we are again joined by 4788 from Perth in WA. Very excited to have them back for another interesting presentation. I've been describing it as technical processes, but I'll hand over to the folks over in WA now to give us a bit of a summary and a look ahead at what's coming up. Thank you.
Awesome. Thank you so much for that, Mel. So today we're going to start off with a little bit of background about the 4788 team. So could you tell us a little bit about how many members and the age ranges that you guys have?
Yeah, for us, we've got around 25 to 35 students, depending on the year. All our students are within the age ranges of year 4 to year 12. We've also got around 10 to 15 mentors who are primarily university students and also some industry mentors.
Great. And we'll move straight into how you guys do things technically throughout the season now. So if you could give us a little bit of elaboration on how you utilize CAD historically and in the present.
We utilize CAD now to design. We utilize CAD now to design all parts of our robot to ensure that we can manufacture everything with various machines that we'll talk a bit about later. We design all of our parts, make sure that nothing intersects with each other. I'll let that how we've done it in the past.
So historically, we've been around for quite a few years at this point. When we first started doing our robots, we built relatively simple robots. Our motto for a long time was simple but effective. So when we were first starting out, we didn't spend very much time CADing. We just put stuff on the drive base and played around with it and made it work. But as we got better and we learned more as a team, we wanted to build more competitive, more complex robots. So as we did that, we found that we needed to spend more time CADing to make sure that they were going to work as a whole system, not just as individual mechanisms that can't work together. So that kept growing more and more until these days we pretty much have to CAD all of our robots entirely, and because we don't make any parts by hand, just assembly. So
it's pretty cool to hear. Before we move on, I've just realized I forgot to introduce who we have here with us today. So would you guys like to introduce yourself and give a little bit of a tidbit about who you are and what you do on the team?
I'm Robert. I'm a lead mentor here. So I've been on the team as a student since late 2018. It's not that long ago. So I'm also a university student. I work as an engineer.
I'm Billy. I'm a student on the team primarily, and I've been on the team since 2023.
I'm Jade. I'm primarily a programming student on the team, and I've been on the team since late 2022.
Awesome. Thank you guys for that. Now, moving on, so we've talked a little bit about your CAD, but moving on to how that transformed into a physical machine. What machines do you have, and how do you have access to those?
So we have a variety of machines. The one that we utilized the most last year was a CNC router designed by a couple of our mentors. That was great for us because obviously being operated by our mentors, it was able to work very well within our schedule and keep us on track. We also have access to some very complex CNC machines through DSM Engineering, where Robert works, and also the Curtin University technicians. And along with that, we also have access to some other machines such as lathes at a local makerspace called the Art Factory.
Awesome. And when you're creating your pieces for the robot, do you do any iteration at all?
We do a lot of iteration, especially in the earlier parts of the season, where we do a lot of initial CAD, and then we start prototyping. And while we're prototyping, we make an alpha bot to prove a lot of our concepts and make sure that programming has some time to test some stuff. And from there, we iterate until we get to our competition bot or our beta bot.
We also do a lot of iteration in our software. We go through often large refactors throughout the season and over the off season to try and get it into something that's very easy and quick for us to work in. We do a lot of iteration in our tuning and the different way that we structure things. and so that we can effectively meet all of our game goals.
Ongoing iteration is a really important part for us. It's one of the keys to success of main teams. We agree with that. So it's also like we continue iterating all the way up to the event. It's not uncommon for us to be making major changes right before unboxing the robot. Like last year, we went through about 3 intakes in the last week before we went to Sydney.
That seems like it's a lot going on. So how do you guys sort of manage the timeline of that?
Timeline's been a bit of a tricky one for us. So going from kickoff, we take a couple-day break to recover because we stay up all night to watch the kickoff live. Because we find it's a very exciting thing, good way for team members to get to know each other and bond. Since we're staying up all in the same building, like sleeping over there, we do a potluck often, and we order pizza, play games, that kind of thing, which is just a ton of fun and a really good experience for people to get to know each other. So then we're taking a couple of days to kind of recover from that, then moving into our design, and we want our architecture and our game goals finalized by kind of that first week. Then we're looking at building our first robot, our AlphaBot. So this, depending on the year, we want it done within 2 to 3 weeks, which is going to give us a lot of time for driver training, programming, and auto development. Then after that, we move on to our competition robot, which we hopefully want to have done in another 2 weeks from then, which will let us finalize everything and have it ready to ship over to Sydney.
Great. So you've talked a little bit about how you guys have done things currently, or are doing things currently, but let's dive a little bit into the past. So how would you describe the evolution of the robot throughout the years?
So on our team, we kind of use the term font to talk about different styles of robot building. So other people use design language as a common way of doing it. It's like we think about it as the kind of techniques we use when we're building our robot, right? So in the past, in the recent past, we've been very much on the SHS. Yes, like the tube and gusset plate meta, which is very effective because it's very simple. You got lots of very simple parts, very easy to machine, very easy to iterate, very easy to make lots of adjustments. But we've started moving away from that in the last few years, especially between the AlphaBot and the BetaBot. I don't know if we can pull up the CAD for them to show off kind of the differences. So here is, do you want to go to the AlphaBot? So here you can see a lot of the structure, especially the support, is made from SHS. But one of the issues we had with this was the robot was very top heavy, and then we also focused on very small robots and very light robots, so that made this robot kind of tippy. So we really wanted to move away from having so many large, heavy parts, and we wanted to make the robot a lot more competitive and a lot lighter and smaller. And so to do that, we switched to severely increasing pocketing, a lot more custom parts, especially more complicated parts that would be more complicated but less quantity parts. And we also started integrating a lot of carbon fiber into our design, which is actually really effective. Do you want to talk more about that, Ollie?
Sure. So this year we started using carbon fiber. We were prototyping a lot with using it for supporting our elevator and also as a shaft alternative to hex shaft. As part of this, we developed a lot of different ways to like attach it to things and some custom bushings that mostly we got machined by the techies and by using our router. Yeah, we found it was really, really light and very effective if used properly, which is surprisingly easy to do.
Okay. And how would you describe your font this year for your team compared to other teams?
I think this year our font is a lot more refined since it focuses a lot on putting a lot of thought and process into making sure that the parts that we make are all going to be the best part that could possibly serve the role, which by doing that and having a lot of like pocketing, and very nice connections between everything. Like, for example, with our billet drive base, we've got a lot of mounting slots actually machined into both sides of that. We've got wire routing machined into the underside of it, and things like this make our robot look really nice while also being really consistent and really effective.
Do you find that the changes that we've made to your font this year has been quite difficult to adapt to, or was it fairly simple?
I would say it was difficult to adapt to in one compartment where by making these parts a lot less parts and a lot more well thought out machined parts, it's a lot slower in a lot of ways because you're doing a lot more CAD. And obviously there's that overhead of you need to send a part out maybe to the university techies to get machined or to another sponsor. But we've found it was also really good because it made our competition experience a lot easier as we were a lot more consistent within the matches.
Yeah, I absolutely agree. It was very challenging, very challenging to make this font design switch in season, especially because we had to completely change how we were designing robots halfway through the season, which was when we had no experience doing it this way. So going from the beta bot took a lot longer than it normally we'd like it to do. And it's very hard. I mean, there was a lot of research and development we had to do in season, where we were very pushed for time to get all that done and still be hitting our schedule.
All right, we're going to take a quick pause and welcome our other joiners to today's talk show. If you guys would like to take a seat and introduce yourselves.
Hi there, I'm Mark. I was CAD captain on 4788 for the last 2 years, and 2025 was my final season with the team.
Hi, my name is Toby. I've been on the team since 2022. I primarily work on programming and awards.
Awesome. Thank you guys for joining. We'll move right back into it. So you've talked about your font for this year and the past years, but what does the functional difference look like, and what is it that you focus on when you go to design the robot?
I think the biggest functional difference for us in the change of font compared to the previous years has been the consistency at competitions. This year compared to last year, we had almost no major mechanical or electrical failures during competitions, which meant we got a lot of time to be just sitting in pits enjoying the beautiful look of our robot, as opposed to in previous years where we've had like intakes get damaged and we've had to like completely reconstruct them in the pits to get back out to our next match. It's helped us to be a lot more relaxed and able to focus a lot more on strategy at competition.
Great. Does anyone else have anything to add?
I would also add that we've made some changes in design decisions. So in the past, we've used a lot more traditional FRC parts, things like hex shaft. But this year we tried a lot of new things like carbon fiber shafts. I'm not sure if that's already been spoken about much. But we made a lot more decisions that relied on sort of parts that are different from what you would traditionally see in FRC. Some other examples are obviously the billet drive base. And I think generally we made a design move away from having sort of multiple part structures to having as few parts as possible. And I think that's part of what's contributed to reliability. And I think that's made quite a big difference this year.
Yeah, definitely by reducing our part count significantly, it helps with our assembly time and with our repair time because there's just less parts to take off if we have to take stuff off. It also helps with our reliability because there's just less parts to fail. We use more bigger plates are much stronger, and then even though they end up being lighter.
If teams would like to adapt that sort of strategy, what is the one advice that you would give?
Definitely something I would recommend looking into is carbon fiber. Like we never used it before this season, but it was actually pretty reasonably priced for what it is, and like it's crazy just how stiff and how light it is. It has been a really big help in us cutting a lot of weight out of our robot to like mid 30 kilos, I think, no battery.
I think also focusing on having a very good machining setup was something that really enabled us to focus on making more parts which have multiple purposes. Having some very advanced machines through DSM Engineering and the Curtin University techies allowed us to make some of those more complicated parts.
Yeah, and adding on to what Jay just said, specifically designing parts for the manufacturing that you have access to and taking into account the sort of pros and cons with those different methods. For example, we've got access to some pretty amazing machines through the Curtin technicians, but those come with much longer lead times. So complex parts like that, we can get them made, but we've got to make sure we have parts ready sort of a week ahead, and we're accounting for those delays. But yeah, definitely taking advantage of the capabilities that you have access to.
Absolutely. Thank you guys so much for that. Before we jump into more of a strategic perspective, does anyone online have any questions for us? Feel free to jump off of mute or type into the chat.
Did we make any changes last season to ensure electrical reliability?
So the question was, did you guys make any changes to your electrical systems for reliability purposes?
Yeah. We did make some for this season, but not a huge amount. Things like having wire routes in our drive base and planning things out more in CAD did help, but it is something that we've been looking at a lot over the off season for next season. We've designed custom PCBs to be able to run all of our, I think it's all of our data lines, like all of our CAN and digital inputs through RJ45, which will all come back to hub on the RoboRio. This is really, we think, is going to have a really positive impact on our reliability, as it's going to reduce the amount of long, complex wire runs that we have throughout the robot. And it's going to make it so that if we do need to add something in last minute, which would require often rewiring large amount of things, like say a sensor, then we can just kind of plug it in and get going, as opposed to having to redo a large amount of wire protection and stuff.
Yeah, it also just means so many less wires, right? Because we've got 2 CAN wires, 2 power wires, and 4 digital wires, all in this one, wire that we can just route. So it makes it much easier to plan out how much space we're going to need. Makes it much easier to actually assemble it. Maintenance is so much easier because if you just want to remove it, you just unplug the wire and you can put it and you can plug it back in easily. There's no desoldering, and it's just one connection gets rid of everything.
Great. Any other questions? How do you design for plane transport?
Big thing we focus on is trying to keep our robots light. If we have a light robot, then if it's light enough, then we can actually ship it in one piece on the plane. This would be the dream. It has not happened the past few years. But yeah, that's a really big thing, which we try and focus on, because the less that we can take off the robot to ship it over, then the easier it's going to be when we land for a competition to be able to reassemble our robot, and we'll have less failures.
Yeah, basically what Jade said, this year we actually got the closest I think we've ever been to being able to ship the robot in one piece. We had one big box the size of the robot, and we just took off the swerve modules to remove some weight so that it fit within the baggage limit for the airline.
One of the other things that's been really helpful is we have a very generous sponsor who will make custom sized cardboard boxes for us. So we just and they'll do it very last minute. So we can just say, okay, this is how big the robot is going to be. This is how big all the stuff we're taking off is going to be. You can get a box that's exactly the right size, very tough, very durable, very easy to work with. And we can get that, they donate that to us for free every year, which is super helpful.
That sounds like you have a really great sponsor there. Do you guys want to talk a little bit about the lessons learned over the past years on how to package your robot for plane transport and some of the design iterations throughout the years as well for that?
One specific anecdote that I remember is in 2024, we had a large arm in our robot with an absolute encoder that was geared to the arm. But when we took the arm off and then put it back on, the encoder had moved. So we started running the robot, and the arm just immediately crunched into the robot. And we had to make some last minute fixes. So I think it's mostly just reducing the number of things that have to come off and making sure that we have a very clear plan of what needs to be put back together and how. Like we've done checklists in the past, which is quite helpful for when we're reassembling the robot.
Yeah, there's definitely lots of things to go wrong when you take apart your robot. Like we can go all the way back to 2019 with a kill switch on our robot was not fastened down properly for a long time, like the electrical connections. So our battery would just die really quickly or would just cut off halfway through the match because that took a long time to fix. So these days we also try and keep as much of the important stuff on one side of the robot as possible, because really you shouldn't have to take the kill switch off your robot, right? It should be all with your drive base and all of your core electrical should go in one box, and then anything else can go in another box. So designing in those separation points, which make it easy for you to take things off, makes a really big difference in trying to work out later how are we actually going to get this robot down to the weight limits.
One thing that also helped this year was the part of our robot that we took off primarily was the swerve modules. And since we were using the CTRE swerve generator, it was very easy to, even if we reassembled it in a slightly different order, we could just go through the generator again, which will take us less than 20 minutes. And then from that, we know that it is going to come out and it will fully be able to work again as it was, versus with something like Mark mentioned with the arm in 2024, we didn't have a plan in place for verifying that it was back in the right spot.
Great, thanks for that. Any other questions from the chat? No more questions from the chat at this stage. Great. So before we move into strategy, as I stated earlier, we're actually going to jump into programming, which I have completely neglected. So what is the key features that you guys use in your programs?
The key things that we used in our code this year, number one is definitely going to have to be WPI-libs command-based. We really built our architecture around having simple commands, which we could compose together using triggers, trying to drive all of the actions on our robot by the state of different sensors and obviously the driver input. One of the second most important thing was probably going to be Advantage Kit and Advantage Scope. Those were wonderful tools that we discovered over the off season, which allowed us to log all of the data within our robot and be able to then analyze it in Advantage Scope, which is a software which allows you to view the different states of the robot and view lots of different types of data in different ways. For example, it has statistics view. This also gave us access to a feature called Replay, which was super important for us developing our vision, as we were able to actually see where the robot would have estimated it is if we had made certain changes in the code. For example, we were able to add filtering for ambiguous tags from our gyroscope between events without having to do any testing on the robot for that. It just worked when we threw it on, because we were able to take log files from previous events and then run through that with Advantage Kit's Replay until we were happy with the performance we were getting. Then moving on to vision, like we discussed, this year we started with Limelight, then moved over to Photon Vision. Having full field localization has been really helpful for us. First of all, we're able to actually see the paths that we're taking around the field. It's useful to be able to look at for like strategy or how the driver's doing, give them some of that feedback. Because we can see where they've actually gone and where they might have been able to improve. Along with that, it also helps us do auto align during the teleop period and also improves our trajectory following during autonomous. For our autonomous period, we use Choreo. For our autonomous period, we use Choreo, which is a software that we actually help develop, which does trajectory optimization using the kinematics and dynamics of the swerve drive base and arbitrary user constraints to generate time optimal paths to go from point A to point B. So we can do things like setting acceleration limits, which was helpful with our AlphaBot as it was really tippy. And it will also, we know once we've generated that path and once we've gotten like one or two paths working, we know that it is always going to work because it will follow the constraints of our robot. And we know it will always be the fastest path to get to that point. Another thing that we looked at throughout the season was also different ways to approach from a dynamic position, approach a position on the field, such as aligning to the reef pegs this year. We had a look into using a global vector field, something which we found was useful for helping us to avoid obstacles, which when we were initially planning to be pathing from longer away was super helpful, but didn't end up being super useful for us for champs, as we were relying more on the driver going to a point directly, which allowed us to really simplify our control scheme and get a lot more driver training, as we had less software testing that we needed to do.
I think a very important part about software in 4788 is the training and the education around software and code in our team. As Jada has very well mentioned, we do a lot of really advanced software and programming on 4788. So it's important that our students feel confident and comfortable learning these topics and going through season. So this season has been quite new. 4788 has had a very complicated history when it comes to our software libraries. We've gone through quite a few custom libraries in very recent years. And I feel like landing on command-based with AdvantageKit is a very comfortable ground. So we're definitely sticking with that for now. When it comes to teaching students, especially brand new students who haven't programmed before, we decided to kind of ease them into it. So we've began with a timed robot template, so they get exposure to Java concepts like variables, loops, functions, things like that. And then we move into command-based, and then finally add on the AdvantageKit. The really cool things with AdvantageKit is that due to how easy it is to simulate robots inside of it and using AdvantageScope as well, it allows us to teach these concepts and then have immediate feedback. The student can see that, whoa, all the skills I've learned, all the things that I've done so far can then lead to this, this virtual 2D arm moving. And I can see that the graph is showing the data I wanted to show. It's a really cool tool for teaching and empowering students through software.
Another thing that we are working on in the future that we've struggled with this year is making sure our development order in programming is better structured. So this year we were doing some really awesome testing where we were running the robot fully autonomously for most of the match. And so, because the game path is very simple, the robot was actually super effective at this, but we kind of structured it in a weird way in where we spent a lot of time getting the fully autonomous cycling working, but we didn't have a lot of the actual features of the robot that you need to make any of that work, like intaking the coral, raising the elevator. And so having that really weird alignment meant that when we got to Sydney, we actually had this really cool driving system, but we didn't have the rest of the robot fully hooked into that. And even that was not as well tuned as it could. So something we're going to focus on moving forward is making sure we're starting with the basics and then building up to the advanced features where we want to finish. And then if we, run out of time halfway through, we've still got all these actually really useful basics to make sure that we're ready for our event, whenever that is. And it also helps us with actually being able to driver train earlier, because we did not spend very much time driver training before Sydney this year.
Cool. Thank you guys for those such elaborate answers. But you guys have talked about what you guys have done previous to the competition on how you would train your students and make sure and use AdvantageScope to help develop those programming skills. But what about what happens during the competition? What about some of the pressure points and troubleshooting things that you guys look into there?
So this is probably one of the biggest areas where we improved on this year compared to previous years. During the competition, having access to log files on our robot that are logged by AdvantageKit with all of the data required to replay on our desktop the actions that the robot did take and the actions the robot would take has allowed us to find and fix some really difficult and challenging bugs during the competition. So AdvantageKit logs data in 2 points as inputs and outputs, and then you can actually replay all of your inputs to get a new set of outputs, allowing us to do things like tune filtering out vision targets during the competition, which allowed us to ensure with 100% confidence that when we go back onto the field, it's going to work, and we are going to get more accurate estimations than we were previously. We have also been able to use that data to find some tricky bugs. Like at Warp this year, the field was actually misconfigured and allowing driver stations to connect to robots before the driver station had been configured with information like the Alliance side. which meant with the way our auto alignment was structured, we would try and align to the opposite side of the field, and it would detect that was wrong and crash the code, which obviously was very bad because we don't want our code crashing the first time our driver tries to align to something on the field. And by having all of the data from the driver station logged, we were able to actually see that chain of events. Okay, we're getting the wrong data initially. The FMS shouldn't do this. Why is it doing this? And then we were able to see that we were getting an FMS connection after a driver station connection when they should have been happening at the same time, which allowed us to then go and talk to the FTA at the event and find a fix.
Absolutely.
So just expanding on, you mentioned something, like pressure points and stress points during season. Since we're, developing such, innovative solutions during our season, it can be quite stressful. And I think we're quite lucky to have such a large spectrum of problems to solve for season. It can be as simple as programming a subsystem to, turn a motor or a PID loop, or it can be some, really crazy problems trying to fix, like, Jade does some amazing work with the automation and the simulation and the logging side of things. So I suppose the first step to alleviate some of the stress during season is getting students directly involved with AdvantageKit during the preseason. Make sure that, it's not a huge shock when jumping straight from just command-based or even a timed robot to AdvantageKit during season. Get that early exposure and get them, learning and feeling confident early on. And then we can kind of break up the problems into, if you're, new to programming, here's the intake, here's an ARM, create a PID loop. Whereas if you really want to, test yourself and, really learn some exciting things, we have the opportunity to teach those things because of how much we're innovating with our software. I think that's really cool.
Yeah, no, absolutely. And with all of that innovating and the training that you're doing, how would you train the drivers during competitions as well? What are the kind of the steps that you would take to ensure that the drivers are ready for the next year?
I suppose the main point is, probably the main person to talk to. But I think, Robert?
Sorry, well, I missed the question. Can you go again? I picked up some of it, and I knew. But
essentially, what are some of the training that you do for your drivers during a competition to make sure that they're ready, for new drivers during a competition to make sure that they're ready for the next year?
So one of the things we do is we always ensure that our driver for Warp is going to be the driver for Sydney following. So that means by the time you get to your official regional, your driver has already gone through at least one real event and has 2 events worth of driver training behind them. And we've seen that's made a huge difference in the driver quality at official events since we've been doing that over the last few years. The other thing we do is at the events, we're reviewing our logs from the thing. And it's like, this is what we could be, this is where we got stuck, this is why we got stuck. How can we be making sure we're going to do better in the next time? And how can we make sure this isn't going to be a problem in the future, which is sometimes some mechanical fix, sometimes it's programming fix, sometimes it's just being aware of this issue, and this is the solution to that issue that we can work on. Then, like, driver training is such an important part of it. So one thing, when we're building the AlphaBot, we try and get that done about Australia Day is the goal. So that gives us like a whole month with a fully functional, almost competition ready robot. We can be spending all that time driver training, which helps so much. It makes such a big difference.
And we're also trying to use that information that we're getting from the logs on the robot to help our driver while they are training, not just at the competition. If we identify things like maybe inefficiencies in routes they're taking or something like that, we actually have adopted a tool this year, which we saw from the Drop Bears. We adopted it for Warp, which allowed us to actually look at the time between intaking and scoring a coral. And then we could look at that and see, okay, where might be the bottlenecks? Is there maybe defenses playing into it or something like that?
Yeah, great. Driver training is absolutely really important to make sure that you have a sustainable team as well. We're going to take a quick pause and check if there's any questions from the team online.
How large is the CAD crew and what does the alpha beta delivery timeline look like?
Do you want to speak that straight into the microphone?
How large is the CAD crew and what does the alpha beta delivery timeline look like?
So we have a CAD team of probably up to sort of 15 students during season, all sort of taking part in various levels of the CAD. So the way we structure it generally is we have CAD captain who sort of oversees the integration and sort of makes sure all the subsystems are tracking. Then each subsystem has a lead who does a lot of the CAD work for that subsystem. And then people will be split up between subsystems to help work on smaller tasks. Sorry, what was the other part of the question again?
What is your alpha beta delivery timeline?
Oh, yeah. So as mentioned before, we get the AlphaBot mechanically done by Australia Day on the 26th of January. So that normally means sort of CAD done within the first 2 or 3 weeks. So it's a pretty tight crunch for the AlphaBot. And then we start CADing the second robot almost as soon as that robot is constructed. We do have quite a big overlap between our CAD and mechanical teams. We don't really have a specific manufacturing team. So it's kind of like the robot is CADed, then everyone constructs it, and then we go back to CAD for the next robot.
And that CAD for the next robot takes pretty much anywhere up until we need it done to ensure that we have a lot of time to iterate and make sure we have the best beta bot possible for the competition.
Yeah, cool, absolutely. So you guys, we've talked a little bit about the season timeline, and we're talking a little bit about how the constraints you have here as well. But are there any other external factors that constrain your timeline and the amount of weeks that you have to actually work on the robot?
A big factor is the university semester. We are based out of Curtin University, obviously. So we use the university space, which is also used by students. So we can start with access to a large building during the university break, but then around sort of week 4 to 5 to 6 of build season, we get kicked out of there because university comes back, and then we're stuck in a much smaller storeroom without much room for a field. So we kind of have to use a much smaller space for driver training. And that definitely affects how we structure our season. We try to get as much done as possible while we still have access to the larger space, so we can test and do driver training on a half field before we lose that space and have to make do with a much smaller space.
We also have the impact of, obviously, our closest regional is over in Sydney, which I'm sure for a lot of you is very close, but for us, it's many thousands of kilometers that we have to fly, which also means we need to adjust to the time zones. We need to adjust to like reassembling our robot, and all of that means we have about a week of our build season, which is devoted to traveling, getting over into Sydney, getting into our hotels, reassembling the robot and all of this, which cuts into our time.
Another big constraint that we have to work around is our manufacturing time. And so we have lots of different machines that we have access to, but all of them take different amounts of time. Like we can 3D print a lot of the parts same day, but we can sometimes get some parts CNC routed next day or day after, depending on mentor availability. But like techie parts from the Curtin machinists can take up to a week or two. So we need to really focus on different parts that we know are going to need these different manufacturing methods. We can start with the longer lead time parts first, make sure they're ready, and then we can ship those out while we're still working on the rest of the robot, so that we can actually get all our parts in time for us to assemble the robot as early as possible.
And what are some of the key things that you guys keep in mind, or key steps that you have to make sure to fit these constraints and make sure that you can finish it within the time limit that you guys have?
With regard to manufacturing, like Robert's mentioned, this is probably an area that we can still improve quite a bit in, but we try to have sort of spreadsheets detailing all the parts, sort of priorities, manufacturing methods, and then we can track where parts are at in CAD, get them manufactured as soon as they're ready to go. And that generally helps us manage our time and make sure we have the parts when we need them. But we've still had some bottlenecks with manufacturing this season, and I think that's something we'll try to improve for future seasons.
Yeah, one of the techniques we're also looking at for improving this is we're considering creating a fabrication captain role. Even though we don't really have a fabrication team and we don't make parts, it'd be more about their role would be more to focus on explicitly keeping track of where parts are at in the fabrication step, right? What needs to be sent out, what needs to be bought, when all these things are going to be done by, and so when can we pick them up, and how much of the robot can we have built before we need those parts.
Another thing that we also try and do, particularly to keep everyone on the same page, is we do meetings this year. I think it was at the beginning and the end of every day to kind of be like, okay, here's where we're at, here's what we want done, and often like, here's what's going to need to be done, especially during the school term where we might have 2 or 3 days between sessions. If there's CAD or programming or something like that needs to be done at home before a session, so it can be assembled or be sent out to be machined or something like that, making sure that stuff like that is checked in on and making sure everyone knows what they have to be doing, so we're all working together as a team.
Absolutely. If there's one key advice you would give to teams that have similar time constraints, what would that be?
One of the key things that we've learned recently and we've been really focusing on is, as part of our architecture, to just cut as much stuff as possible, right? Like the first thing we do when we look at a game is, what is everything we don't absolutely have to do, and let's not do it. And so that just reduces how much we have to do by so much. It means that the stuff we do can be a much higher quality. So that really helps us keep within our timelines.
Particularly for the programming, simulate everything. You can get, with all the modern simulation tools that are available through WPI Lab particularly, and often vendors, you can really get all of the high level logic of your robot tested, even a lot of the tuning, and you can really cut down the amount of time that you need to spend on your robot, which means that even if you do end up getting a robot very soon before competition, then you're going to be able to just kind of go on there, check some IDs, get some control loops tuned, and then be running up and well at the best performance you can be.
I think also doing as much as you can in the preseason is very helpful as well. Obviously, making sure everyone is trained up in the preseason so that they can jump straight into helping out with useful tasks during season. And also, last season, we built a practice billet drive base, which was machined out of HDPE. And doing that in the off season gave us a lot of useful experience that made the drive base design much faster during season, and also gave us a base for testing, programming, and driver training at the start of the season.
As like Robert mentioned, with like trying to get like a fabrication captain going, and Jade mentioned the team meetings, primarily for the limited time we have access to the larger building, make sure your team is just communicating very well. Like we subdivide quite strictly into like, with programming, CAD, mechanical, possibly machining soon. So make sure that, they're checking in regularly. People aren't getting burnt out. If this is falling behind, we need to allocate some more people or time or resources to this area. Just communication. It's an obvious point, but it's still important to mention that, make sure everyone feels heard and is working well together.
Definitely for driver training stuff, the stuff that Jade was talking about before, with like monitoring the inputs and outputs and stuff of the driver is really helpful, especially if you don't have like a full field or don't have space and time to set it up and stuff. It's very helpful for driver training.
Yeah, great. Awesome. Thank you guys so much for that. Any other questions?
Some questions from the chat. How big is your software team?
This one varies year to year a lot. I think this year we were around 3 to 5 people.
Yeah, I think that's pretty accurate. I think it's like a sixth member. I think six. Yeah, it does fluctuate a fair bit. It depends. Gosh, about 6 or 7 maybe. It does fluctuate. It's probably a point that we need to work on more, is kind of make sure that people are staying engaged throughout the season, especially towards the end of season when the standard of work does become quite high. Make sure students are still feeling engaged with the software and feeling like that it's approachable and able to pick up the concepts and contribute meaningfully. I think it's a very important point to work on in the future.
And this is one thing that I think with the new training stuff we've been doing over the off season will help a lot with. It's like, making sure that students have more experience and exposure with kind of the software and the different things that we do. It means that they'll be able to contribute more in season, which means they'll be more engaged and then hopefully come back and do more software next year.
Yeah. Anything else from the chat?
Does 4788 have a particular focus on developing FRC software tools outside of Choreo? If not, do you have any future goals relating to contributing to other libraries as a team?
As a team, we have quite a history actually going back, and contributing to software throughout the FRC ecosystem. So we actually, back when we were two teams, a student at the time on one of our teams developed software called Gradle Rio, which is now used by all Java and C++ teams. And then while it is often more done individually, our kind of contributions to outside software, we have contributed even in recent years to WPILib, to software libraries like WPILib, which is used by all teams throughout the competition, and also vision software like Photon Vision. And we really do try and give back to the different pieces of software that help us succeed.
One of the things we are working towards though is in the past we've been very much a go it alone, do our own implementation of whatever problem we're solving. One of the things we're focusing on these days is we're trying to use existing solutions which make what we're doing more effective. And so it requires the team to do a lot less development. So we end up supporting these things in other ways than just actively writing code. So like sharing, creating training resources, using it with the rest of WA teams who should making them available, that there's all these resources available whereas possible. And since we know how to use them, we can now help all those other teams use those same resources more effectively instead of just trying to use our custom archaic thing that only we know how to, which buttons to randomly press that you have to make it work. Right.
I think Toby's got a question or answer.
I think a cool point to mention is that, all of this awesome contribution to the tools and development side of, Choreo and WPILib is never really expected of our students. The primary focus during our season is, the robot functionality, but we see it every year is that students want to branch out and sort of give back to the FIRST community, work behind the scenes, work on WPILib, work on Choreo. We've seen, custom vision systems. We've seen custom PID tuners. It's really exciting when students expand themselves outside of just 4788 and try and work on FIRST software as a whole. I think that's really cool.
And I think we also see the benefits of students going out, coming back into our team by being exposed to a lot of these projects and maintained, particularly WPILib, by teams of very experienced software engineers, which means we can kind of learn practices and skills from them, which then get brought back into the team and reflect in the way that we do things.
Great. It's really good to see that the kids and the students that we train up are then contributing back into the community and keeping that cycle going. And that's how we make sure that the program is ever continuing. Now, any other questions from the chat? All right, sounds good. We'll move on into a little bit more about your team strategy now. So you've mentioned that you're trying to develop more of a fabrication captain, but could you give us a little bit of a deep dive into the current team leadership structure?
So for our team leadership structure, we've typically had one team captain whose role is kind of managing our sub-team captains and making sure that all of the sub-teams are keeping on track with time. They're reporting back. Everyone knows what's going on with the other groups in the team. Then we've split up into more sub-team captains, such as programming, CAD, awards, which have then focused on individual tasks and making sure that the groups within those teams are meeting deadlines, they're staying on track. If budget stuff needs to happen and we like mentors to purchase something, that's being communicated back up, and we're keeping all of that stuff very well managed. And then within that, we kind of split up again often into, and this does depend on, do we have a lot of students that year? How complex is what a specific task is? We'll have people within those groups who are leading specific tasks or specific items. Often, like was mentioned earlier with CAD, like having someone who's leading the prototyping, the development, and the CAD for a subsystem, allocating different roles to people. So like, oh, you can CAD these plates, you can CAD this part, and then making sure it all gets done and is reported back up.
Yeah, one of the things that's really important to us when we're talking about leadership is the team lead is never has more decision-making power. It's not their job to make decisions. It's not their job to tell other people what to do, right? Their role is to keep track of the progress of the whichever part they're leading, to support it, to ask for help when that area needs more help to hit the deadlines that we do need, to make sure it's easy for everyone to understand where their thing is up to, so you don't have to go find half a dozen individual people and ask them what their part of the subsystem is up to, right? And so that applies especially even more so to the team captain role, who's like, their job is not about like running the team or maintaining the team. Their job is to run team meetings, is to make sure that all the subsystems are progressing on time, to be aware of how far along each thing is.
Do you think the team structure has evolved over the years?
For sure, it's definitely evolved. In the past, we've done a lot of things very differently. So in the long ago, when I was first joined, we would have a captain and a vice captain, and then we would have sub-team leads. And back then, if you weren't a sub-team lead, you ended up doing a lot less of the robot and not having as much opportunity to engage. So we really worked on that. And at one point, we also had 2 team captains, and that did not work very well, because there's not really any advantage to, other than just because the team's captain's job is to run the meeting. 2 people running the meeting is not helpful. It just makes the meeting more challenging to work with. So I think we applied the whole simplify approach to this and be like, cut everything that we don't absolutely need, and that includes in the job description of these captains.
Great. So talking about the strategy that you've adopted in terms of simplifying things, what was your kickoff strategy for this year?
So this year, when we were looking at the game, we tried to find what was the least amount of things that we could do while still trying to be able to fill a key role on kind of a top alliance, right? So when we looked at the game, we saw that most of the points that are being scored are probably going to be coming from the Coral. The cycles for the Coral are very fast, and there are a lot of points from each cycle. But then we identified that we probably didn't need to do the L4s, as all of the good teams were going to be attempting to do the L4s. So if we focused on building a simpler, faster robot that would be able to do more of the L2s and 3s, then we would be able to be in an alliance with 1 or 2 really, really strong L4 robots, and then they would be able to focus on that, and we would still be able to contribute a lot of points to the team by scoring a lot of L3s and L2s.
Yeah, we approach it, I think, in a way quite similar to a lot of teams. We start off by doing points analysis, which I think is quite important, where we list out all the ways of scoring and how much each of them is worth. And then we also estimate sort of rough comparisons of how long each one will take. So we identified things like L4 would likely take longer because sort of you're reaching up higher, your robot is less rigid, things might sort of wobble around, need more time to settle, in addition, obviously, to the robot complexity. And then after we do that initial analysis, we divide things up into needs that the robot will definitely need to be competitive, wants, which is sort of for us a category of things that would improve robot performance, but it's more dependent on how the robot architecture comes together and whether that's easy to fit in with the rest of the robot design or not. And then things that we immediately rule out as being sort of too difficult and not contributing enough points, or more than being too difficult, not contributing enough points for it to be worth it for us.
And was the general kickoff strategy that you guys have adopted this year something that's always been in place, or has there been refinements done over the years?
It's changed a little bit, and I think it's generally just become more streamlined, and we've taken out the bits that don't help as much. I know in the past we've done sort of robot priority lists where we list out things like reliability and fast cycling, and those things are good to keep in mind. Like, it's good to have a list of sort of robot goals, but when it comes to sort of ranking them in order and things like that, we strip back a lot of things like that we were doing at the start of season to really focus on the most important things, which for us are the points analysis and then deciding which of those the robot will do.
We've also in the last few years, we've been really working on the just remove everything that we don't absolutely have to do. Right. If you go look back at some of our earlier robots, especially from the 2021, 2020 period and sort of the 2023 robot as well, it's like, let's do everything. Like we have the capability to do that. And we did. We built robots that were capable to do everything that the top level robot would do. The problem was we didn't have the capability to do that to as good of a standard as we wanted. And so the robot ended up scoring much less points than being much less effective than if we built a simpler robot. So we saw this and we've been really, really pushing to be so like delete as much as possible, right?
And for this year, how did you guys come to the decisions that you made?
Well, so we looked at this points analysis and we saw, well, roughly within a point, it's like 1 point per cycle per game piece, right? So like basically basically just want to do as many cycles as possible to score as many points as possible. And so for us, that's like if we don't want to do algae, we think we can do more than 9 cycles, and so at that point we're going to be out of algae, and we don't want to have a separate mechanism to just be scoring this one game piece that we're only going to be doing some of the time. We're going to focus on doing the coral because that's going to be doing it, right? And we're like, well, we think we can do 6-second cycles at our peak, and that's going to be a lot more than 12 game pieces. So presumably other teams are as good as or better than us. So they can fill the top L4 solo. So why would we do L4, right? Let's cut that as well because we don't need it, right? And then it's like L1. We probably won't, in most of our matches, especially in Sydney, we're probably not going to be filling L1, probably not going to be filling L2, 3, 4, and all the algae. So we don't really need to be very good at scoring L1. And even if we were, we can just get some of our teammates to start scoring L1s earlier, and then which leaves us the space to keep scoring L2 and L3, which is something we're having to do at champ sometimes. And so that just meant that by only scoring on 2 locations out of like 6 or something, we just cut so much complexity out of our robot, which helped us be better at the things that we were doing and helped us just be faster.
Great. So we're running a bit short on time now, so we'll jump into a bit of reflection questions. What surprised you guys most about the robot that you ended up creating? And what do you think would have surprised 1 year ago you?
I think the thing that would have surprised me the most a year ago was just how consistent our robot was this year. I think we mentioned earlier there were like no major mechanical or electrical failures on the field. And if there were any, they were really out of our hands. There wasn't much we could do. And I think if I look back at our competitions in the past few years, there were a lot of big catastrophic failures. We were coming back to the pits and we were going, how are we even going to make it to our next match? But like, I can only think of maybe one time where we were worried about making it to our next match at a competition. And it was after we got beached on an algae and then had the top half of our robot smashed into by another robot, which is kind of out of our hands. So it's like, I think that really would have surprised me a year ago, just the fact that we were so consistent throughout every match.
I think, yeah, I was quite surprised at how, and proud of how consistent and effective it was at its one goal of filling L2 and L3. There's been robots in the past, like primarily 2023, where we've designed, constructed, and completely scrapped entire subsystems and mechanisms. I think this season was a really good example of how being very quite cutthroat with our ideas early on, of just with a combination of points analysis and prioritizing simplicity, we just removed L4, removed algae, and we're able to really, really focus on one thing, and I think executed very well.
The part that surprised me the most was just how useful carbon fiber is. So we'd never used carbon fiber before, like halfway through season. When we got some, it was like, wow, this stuff is crazy. It's just ridiculously light. It's stiffer than aluminium the same size. And so we would just ended up using it absolutely everywhere on the robot because it's just so good. And it's really not that hard to work with. Just epoxy some stuff in the ends and you're good to go. So I would totally recommend try experiment with carbon fiber if you can. It's so worth it.
My main takeaways are much the same as everyone else. Something else I would add though is I think moving to Onshape was a really positive change. there was a lot of sort of debate and uncertainty initially discussing switching from Inventor to Onshape, but I think it made a huge difference in terms of collaborative CAD work. We were able to split up tasks much more effectively because it's much easier for someone to CAD a small part and it's just there in the robot. Previously, we didn't have good file sharing systems, so someone would have to download the tiny spaces someone made and import it into the main robot assembly and try to find where it fit in. But Onshape has made a huge difference in terms of allowing everyone to contribute to the robot more.
I think what probably surprised me the most was how like compact our robot was, especially our final robot with all of our gearboxes like pretty much on our drive base, where at the lowest extension of our elevator, all of our heaviest components were like below the bumper height, which was really good.
Great. And last question from me. If there was one thing that you've learned in your time at FRC that you would share, what would that be?
Probably how cool programming is. I wasn't really into programming that much before I got into FRC. I'd done a little bit of blocks in first LEGO League, but it wasn't really something I was super passionate about. And now it's probably something I'm looking at going into a career for. So definitely, if you're sitting at home, if you've never tried it before, would recommend. It's pretty cool.
Not too far off from Jade's thing, but definitely CAD. CAD is very cool. I actually really did not like CAD before I joined the team, but now I really do like CAD, and I also think it's definitely something I want to do. But also, teamwork as a whole is something that was really good to learn.
One of the big takeaways I've had from the team is just how much is possible that you would look at that and think, well, it can't be done. Then you just go ahead and we just do it all the time. And it's just like, wow, you can just do that. And it's really not that hard. There's so many opportunities and so many resources that you have access to that you just don't know about until you look for them.
I think my takeaway is pretty similar to Robert. It's been very inspiring, I think, for me to see all of the things that are possible. And it's really sort of solidified for me that I want to go into engineering as a field.
I think my main takeaway is that it's how important it is to expose yourself to different ways of thinking, to different people, to different backgrounds. You know, I've met so many people through not only Australia, but globally, thanks to FIRST, who I wouldn't have met otherwise. And I've learned so much from other people and how they think that I think that's very valuable and I'm very grateful for that.
All right, awesome. Thank you guys so much for your answers. We'll now turn it back to the online chat for any questions to the team here.
All right, guys, we've got a couple of questions here, starting with what communication and planning tools do we find most effective?
We use Discord for all of our team communications. So we have just a big Discord server. Yeah, there's not a ton to it. It's just a Discord server with a bunch of channels. It's good because so we split up our channels into kind of like general things, robot things, and then kind of outreachy things, which it's great because it means we can have a lot of conversations going on at once without like people needing to like find messages between different things and stuff. Discord's also good because it's pretty easy to set up. Like it's designed for a few friends at home to set up a server, which makes it really easy for us. It's pretty low overhead compared to something like Slack might be. And people often already have an account. They're sitting at home. They might play a game which has a Discord community, which means it's a really low onboarding.
We don't use any like time management or planning things like Trello or Monday. For us, they just add too much overhead because we work very closely as a team. And we have regular meetings, so we know pretty well where everyone is at any one point in time. If we had a lot more students, maybe that would be different. Or if we worked on projects for longer or more independently, maybe it would be different. But we find that it's just so much easier to have regular meetings and just keep the meetings very short, very sharp, and that helps us. That does all the things we need without having to have this extra service that we also have to spend time maintaining.
Mainly for the award side of things, like very simple tools like Google Docs and the Google Drive are very helpful. It also would be impossible to create this, huge essay without the live sharing features, that the comments, in order to see, live feedback and sharing and seeing the essay really come together when you're having, quite a sizable team working on the not only the essay but the executive summaries as well. It's very useful to use Google Docs.
And on the CAD side of things, we make a lot of use of Onshape features like branches, merging. That's helped a lot for dividing tasks and letting people work on different ideas in parallel.
Branches and merging. On the programming side of things, we try and manage everything through Git and GitHub. It's a good platform for us to be able to have a lot of different people work on different things in parallel. We do find it's often difficult to teach people how to use it effectively, but once people do get up and running with it, it really speeds up the development process and makes it so it's really hard to, even if we screw something up, we can always just go right back to the old state which we knew worked.
Great.
Fantastic. Another question. What does the software team do in preparation for the AlphaBot? So that's the first robot.
Yep. So before we get the first robot, we're doing a lot of simulation. So because we moved to Advantage Kit this year, we were using IO layers for our simulation and basically just using the WPI physics sim and then sending all that data up through to our like top level code. Then in previous years, we've also used the simulation options that different vendors offer. I'm not sure outside of Rev and CTRE, but they both have good support for these things if your team is using their hardware. We also try and often we'll get a drive base. Like this year, we had that preseason billet drive base, and we'll make sure that all of our driving code is just going to be able to get thrown onto that final robot, or sorry, the alpha robot in this case, and it'll just drive.
Yeah, I think Jay covered it very well with just prioritizing a lot of simulation. Something new that we tried this year was using XRPs in the preseason. So that's just the small package robots, which help to bridge the gap a bit more with, it's quite special seeing, your very first robot move and having them work out the box is very useful. They don't work with Advantage Kit so far, but having, we're able to teach command-based and Java principles and have a robot, running PID loops, straight off the bat, which helps get students, prepared and engaged for the AlphaBot.
The other thing we do before the AlphaBot is ready is we spend some time on order because we can get all the paths planned out and we can verify a lot of our theories about how long different things are going to take, so we can make sure is it actually possible to hit these cycle time targets, or are we just not going to have enough time driving to do it? And we also can start driver training as soon as possible, get the driver familiar with the field, how to move around it, where the defense spots are, all of that. So just having a drive base immediately available is so useful.
Yeah, it sounds like you guys are doing quite a bit to prepare your students for the season. Do you want to talk a little bit about the tasks and projects that you do in the off season? Got it. No, that is my microphone.
My microphone was not turned on.
No message is saying, oh, the mic is dead, Robert and Hester's.
Oh, lovely. I turned my microphone off, but it's now back on. The question was, we've been talking a little bit about the projects that you're doing to train your students for the season. Do you want to talk a little bit about on the projects and the tasks that you guys are doing in the off season to do that?
In the past, we've run preseason, which was sort of classroom style lessons in the lead up. And we also expanded that to all of WA with masterclasses. This year, we're doing something a little bit different. And we are doing a more project-based preseason. So for students coming back who have done FRC before, we previously found that sort of our preseason classes would be a bit dull for them and they wouldn't gain too much. So this season, we have returning students doing projects. So we mentioned before the CAN PCBs using Ethernet cables. So that's one of the projects, but there are also things like designing a two-stage elevator and various other projects that get people acquainted with sort of new aspects of FRC design. And then for new students, we do something a bit similar to what we've done in the past. We run some CAD and programming classes as sort of introduction to the topics. This year, we're also making a lot of use of frcdesign.org, which is a great resource. And we've started trying to sort of modify some of it to be metric, so it's easier for Australian students. And then after those initial classes, we've now got the recruits they've CAD'd their own robot for the 2021 power cells to sort of just intake those and a little drive base to drive around. And that's been really beneficial for them to gain some basic skills in sort of all areas. And they're going to be constructing that, and they'll get to actually see it working by the end of our preseason.
And this kind of fits into what we were talking about before with the time constraints as well, because having the ability to make a project that you wouldn't have time to in season and learn the skills, for example, to make a 2-stage elevator, and learn how to CAD that, build that, code that, and with all the other projects as well, is very valuable and I think a reasonably good use of time.
Another thing that we've been looking at is improving our vision system. We had a lot of issues with cost and reliability for vision in the past. Obviously, I'm sure anyone who's had a look at trying to get Limelights, $1,000, yippee. But yeah, so we've been looking at doing a mini PC potentially on our robot for next year, which has involved designing a regulator. We're going to be doing some testing out of that and making sure that it works on a robot and isn't dropping out. And then, yeah, hopefully we'll be able to have a very reliable system for that for next year, which this has given us a lot of time to work on.
Great, thank you guys. Going to the next question from the chat.
The next question from the chat, which we've kind of already covered. Any advice on training new students in CAD skills? A follow-up to that question is, we would love to see the Metric FRC resources go public someday. What can you guys add to that?
Yeah, for sure. I think we'll probably want to refine it a tiny bit more, then we'll definitely be sharing the Metric resources. So far it is just sort of frcdesign.org, but with minor changes. frcdesign.org has been really great as a CAD resource, even without the Metric changes. It's still a great way to get an introduction to FRC design and learn a lot about the different tools and approaches. We're also sort of working on getting some feature scripts that we'll also be able to share for some of our common workflows, sort of, and modifying existing feature scripts that are targeted at Imperial teams. But yeah, I think the most important thing overall is just practicing CAD, and that's why frcdesign.org is great, because it gets you to do a lot of CAD practice. But also what we're doing at the moment, as we mentioned, is CADing the practice robot, which I think is very beneficial to get that hands-on experience designing something new that hasn't been built before, which is the hardest part.
Absolutely agree with that last part, right? The key to being better at something is to practice. And so when we're trying to get people to be better at CAD, we give them things like, let's go design this, let's go CAD this. And by doing that and by providing them real opportunities to CAD and then to also build, because if you just CAD something, you don't find all the issues. You find all the issues when you build it. So we're trying to give as many opportunities as we can to design something and to build something as well. And then you can learn, see, this is the things that didn't work. This is where I could not assemble this because I forgot to check that, right? And so by doing all that practice and as many projects as we can do, I think is the best way to train people to do more CAD.
Oh, right, it is public. If you can go to learn.team4788.com, you can see the work in progress version. It still needs some refinements, but I think a lot of it is there.
I think we're also planning on making some programming stuff available on there. There is some stuff available now or not? Not yet, but soon there will be some programming stuff. We have done some development on it. Then we're also probably going to look at doing some more stuff in R font, because this is very much the standard RHS FRC font, but which is not really the way we work. So we're going to look to train to have those materials for how we design things. It's like billet drive bases and to more complicated single piece parts.
Yeah, great. That's really good to hear that the documentation and some of the learnings that have been applied in the Imperial and the States for many of the teams there is now being adapted for the Australian teams. I know a lot of Australian teams struggle to find information for them, with that conversion being in the way. Moving on back to the chat. No more questions. Okay. Well, we will give it a few more minutes to see if any more final questions come through.
Not CJ has asked us a question. Who is your favorite ex-programming mentor under 6 foot?
I think it's going to be CJ.
I think it's going to be Viola sitting down.
I think CJ really hits the under 6 foot requirement very well. I think he might be under 5 foot actually.
I think if there are no more questions coming through the chat, let's say thank you everybody for joining us. Thank you presenters. Thank you Hester. We appreciate your participation. We will see you next time. I'm going to turn on the chat and we can stop the recording.
Fantastic. Thanks so much, everybody. Really appreciate 4788 putting on 2 great presentations for us over the past couple of weeks. Shout out also to Hester, who has mysteriously appeared on the wrong side of the country to moderate this talk. Next week, we'll be back with another talk, this time from Alistair from Barker, talking about advanced manufacturing in FRC. Thanks so much for joining us, and I'll end the recording here.